CIET NCERT presents the audiobook Ganit Prakash, Textbook of Mathematics for Class 6.
Page number 187. Chapter number 8. Playing with Constructions. 8.1 Artwork. Observe the following figures and try drawing them freehand. You find some pictures given here, like two circles touching each other at one point, two circles in such a way that one lies inside the other, three circles intersecting each other at 2 points. Then we have a cartoon with a face which is circular in shape, and two ears again circular in shape, and two eyes again circular in shape, and a nose which is again a circle, and a straight line as a mouth. Page number 188. Now, arm yourself with a ruler and a compass. Let us explore if we can draw these figures with these tools and get familiar with a compass. Observe the way a compass is made. What can one draw with the compass? Explore. Do you know what curves are? They are any shapes that can be drawn on paper with a pencil and include straight lines, circles, and other figures as given here. We have a curved line, we have a circle, straight line, closed curve, and an open curve. Mark a point P in your notebook. Then, mark as many points as possible in different directions that are 4 cm away from P. Think. Imagine marking all the points of 4 cm distance from the point P. How would they look? Try to draw it and verify if it is correct by taking some points on the curve and checking if their distances from P are indeed 4 cm. Explore if you have not already done so and see if a compass can be used for this purpose. You can start by marking a few points of distance 4 cm from P using the compass. How can this be done? Here you find a picture of point P with points Q and R at 4 cm from each. Page number 189. You will have to open up the compass against a ruler, figure 8.2, such that the distance between the tip of the compass and the pencil is 4 cm. Now, try to get the full curve. Hint provided is keep the point of the compass fixed, moving only the pencil. What is the shape of the curve? Is it a circle? Take a point on the circle. What will be its distance from P? Equal to 4 cm? Less than 4 cm? Or greater than 4 cm? Similarly, what will be the distance between P and another point on the circle? As given in the figure, the point P is called the center of the circle, and the distance between the center and any point on the circle is called the radius of the circle. We can find two pictures here of a compass with a pencil on a ruler. Another figure which describes a circle with radius and center of the circle is at P. The tip of the compass is placed on P with the pencil along the circumference of the circle. Having explored the use of a compass, go ahead and recreate the images in figure 8.1. Can you make the figures as good as the figures given here? Try again if you want to. Also, has the use of instruments made the construction easier? Now try constructing the given figures. Page number 190. Construct. First, a person. How will you draw this? Here we have a picture of a person which has a circle and a rectangle with a curve and a line segment between the circle and the rectangle. This figure has two components. First one is the circle with a line attached to it, and second one is a rectangle with one side as a curve. You might have figured out a way of drawing the first part, that is a circle with a line. For drawing the second part, observe this rectangle and one side is a curve which is drawn with the help of a compass. This challenge here is to find out where to place the tip of the compass and the radius to be taken for drawing this curve. You can fix a radius in the compass and try placing the tip of the compass in different locations to see which point works for getting the curve. Use your estimate where to keep the tip. Page number 191. Second, wavy wave. Construct this. Here we have a picture of a wave with a semicircle above the line and another semicircle below the line. As the length of the central line is not specified, we can take it to be of any length. Let us take AB to be the central line such that the length of AB is 8 centimeters. We write this as AB is equal to 8 centimeters. Here, the first wave is drawn as half circle and the second wave is drawn below the central line and the wave is constructed. Figure it out. First one, what radius should be taken in the compass to get this half circle? What should be the length of AX? Second, take a central line of a different length and try to draw the wave on it. Third, try to recreate the figure where the waves are smaller than a half circle, as appearing in the neck of the figure, a person. The challenge here is to get both the waves to be identical. This may be tricky. Page number 192. Third, eyes. How do you draw these eyes with a compass? For a hint, go to the end of the chapter. We make use of the compass to draw the eyes with two circles inside the eyes. These are in the shape of curves. Make other artwork of your choice with a ruler and a compass. 8.2 Squares and rectangles. Now let us explore at some basic figures having straight lines in their boundary. What shapes are these? Yes, these are our familiar squares and rectangles. But what makes them squares and rectangles? Here in figure 8.3, we are given 4 squares and 1 rectangle. Consider this rectangle ABCD in figure 8.4. The points A, B, C and D are the corners of the rectangle. Lines AB, BC, CD and DA are its sides. Its angles are angle A, angle B, angle C and angle D. The blue sides AB and CD are called opposite sides as they lie opposite to each other. Likewise, AD and BC is the other pair of opposite sides. Page number 193. Recall that in a rectangle R1, the opposite sides are equal in length, and R2, all the angles are 90 degrees. As in the case of rectangles, the corners and sides are defined for a square in a same manner. A square satisfies the following two properties. S1, all the sides are equal, and S2, all the angles are 90 degrees. Recall the rectangle in figure 8.4 and name given to it ABCD. This rectangle can also be named in other ways: BCDA, CDAB, DABC, ADCB, DCBA, CBAD, and BADC. So, can a rectangle be named using any combination of the labels around its corners? No. For example, it cannot be named ABDC or ACBD. Can you think what names are allowed and what names are not? In a valid name, the corners occur in an order of travel around the rectangle, starting from any corner. Which of the following is not a name for this square? We have a picture of a square with S, P, Q, R. First one, PQSR. Second, SPQR. Third, RSPQ. Fourth, QRSP. Rotated squares and rectangles. Here is a square piece of paper having all its sides equal in length and all angles equal to 90 degrees. It is rotated as given in the figure. Is it still a square? Let us check if the rotated paper still satisfies the properties of a square. First one, are all the sides still equal? Yes. Are all the angles still 90 degrees? Yes. Here we are given the figures of two squares, out of which one is a rotated square. Page number 194. Rotating a square does not change its lengths and angles. Therefore, this rotated figure satisfies both the properties of a square, and so it is a square. By the same reasoning, a rotated rectangle is still a rectangle. Here we are given a picture of a rectangle. Figure it out. First one, draw the rectangle and four squares configuration given in figure 8.3 on a dot paper. What did you do to recreate this figure so that the four squares are placed symmetrically around the rectangle? Discuss with your classmates. Question number 2. Identify if there are any squares in this collection. Use measurements if needed. Here we have a dotted paper on which four figures A, B, C, D are given. Think, is it possible to reason out if the sides are equal or not, and if the angles are right or not without using any measuring instruments in the figure? Can you do this by only looking at the position of the corners in the dot grid? Question number 3. Draw at least 3 rotated squares and rectangles on a dot grid. Draw them such that their corners are not on the dots. Verify if the squares and rectangles that you have drawn satisfy their respective properties. Page number 195. 8.3. Constructing squares and rectangles. Now, let us start constructing squares and rectangles. How would you construct a square with a side of 6 centimeters? For help, you can observe the following figures. A square PQRS of side length 6 cm is constructed. Step 1. We construct a line segment PQ of 6 cm with the help of a ruler. In step 2, mark a point to draw a perpendicular to PQ through the point P with the help of a protractor. Step 3. Method 1. Mark S on the perpendicular such that PS is equal to 6 centimeters using a ruler. Method 2. This can also be done using a compass. Page 196. Step 4. Draw a perpendicular to line segment PQ through Q. Step 5. If we had used this compass, then the next point can easily be marked using it. We construct right angles at point P and Q with the help of compass and mark 6 centimeters on each line segment as PR and QS. Step 6. We join the points R and S. How long is the side RS and what are the measures of angle R and angle S? Page number 197. Construct. First question. Draw a rectangle with sides of length 4 centimeters and 6 centimeters. After drawing, check if it satisfies both the rectangle properties. Question number 2. Draw a rectangle of sides 2 centimeters and 10 centimeters. After drawing, check if it satisfies both the rectangle properties. Question number 3. Is it possible to construct a four-sided figure in which all the angles are equal to 90 degrees, but opposite sides are not equal? 8.4. An exploration in rectangles. Construct a rectangle ABCD with AB is equal to 7 centimeters and BC is equal to 4 centimeters. Imagine X to be a point that can be moved anywhere along the side AD. Similarly, imagine Y to be a point that can be moved anywhere along the side BC. Note that X can also be placed on the end point A or D. Similarly, Y can also be placed on the end point B or C. Here you can find figures on this page with the steps given. AX as 5 millimeters and YC as 1 centimeters. We have AX on AD and YC on BC, sides of a rectangle. In another picture, we have AX of 1 centimeter and BY of 2 centimeter on sides AD and BC respectively in this rectangle. In the third picture, we have AD of length 4 centimeters and there is a diagonal drawn BD with dotted lines where D is equal to X and B is equal to Y. In the fourth figure, we have A is equal to X and B is equal to Y and ABCD is a rectangle. Page number 198. At which positions will the points X and Y be at their closest? When do you think they will be the farthest? What does your intuition say? Discuss with your classmates. Now, verify your guesses by placing the points X and Y on the sides and measure how near or far they are. The distance between X and Y can be obtained by measuring the length of the line XY. How does the minimum distance between the points X and Y compare to the length of AB? Change the positions of X and Y to check if there are other positions where they are at their nearest or farthest. You could construct multiple copies of the rectangle and try out various positions of X and Y. How will you keep track of the lengths XY for different positions of X and Y? Here is one way of doing it. Suppose here are some of the positions of x and y that you have considered. First, when x is 5 millimeters away from A and y is 3 centimeters away from B, xy is equal to dash centimeters dash millimeters. Second, when x is equal to 1 centimeter away from A and y is equal to 1 centimeter away from B, xy is equal to dash centimeters and dash millimeters. Third, when x is equal to 2 centimeters away from A and y is 4 centimeters away from B, xy is equal to dash centimeters and dash millimeters and so on. Is there a shorthand way of writing it down? In all the sentences, only the position of x, y and the length xy changes. So we could write it as, we have three columns here: distance of x from A, in the second column distance of y from B, and in the third length of xy. We are provided with 3 rows for 3 different cases here. Page number 199. Have you checked what happens to the length xy when x and y are placed at the same distance away from A and B respectively? For example, as in the cases like these. First one, distance of x from A. When it is 5 millimeters, distance of y from B is 5 millimeters. Then, what is the length of xy? You need to fill. Second row, distance of x from A is 1 centimeters and distance of y from B is 1 centimeters. We need to fill the length of xy. In the third row, 1 centimeter 5 millimeters is the distance of x from A and the distance of y from B is 1 centimeters 5 millimeters. Then you need to write down the length of xy and so on. In each of these cases, observe first how the length xy compares to that of AB. Second, the shape of the four-sided figure ABYX. How does the farthest distance between x and y compare with the length of AC or BD? Construct breaking rectangles. Construct a rectangle that can be divided into 3 identical squares as given in the figure. We have a figure of a rectangle in which 3 squares have been constructed. Solution: if this seemed difficult, let us simplify the problem. Explore. What about constructing a rectangle that can be divided into 2 identical squares? Can you try it? It is wise to first plan and then construct. But how do we plan? Can you think of a way? Page number 200. One way is to visualize the final figure by drawing a rough diagram of it. Here we have a figure of rectangle ACDF and line BE is constructed in such a way that it divides the rectangle into 2 identical squares. What can we infer from this figure? Can you identify the equal sides? Since the 2 squares are identical, AB is equal to BC and FE is equal to ED. Since ABEF and BCDE are squares, all the sides in each of the squares are equal. This is written as AF is equal to AB, that is equal to BE, which is equal to FE. BE is equal to BC, that is equal to CD, that is equal to ED. So, all the shorter lines are equal. A convention is followed to represent equal sides. It is done by putting a line on the line. Refer to the rough figure. Using this analysis, can you try constructing it? Remember, all that was asked for is a rectangle that can be divided into two identical squares and with no measurements imposed. To draw the rectangle ACDF, one could assign any length to AF. For example, if we assign AF is equal to 4 centimeters, then what must the length of AC be? Explore, can the rectangle now be completed? In fact, one could proceed by drawing AF without even measuring its length using a ruler. We could then construct a line perpendicular to AF, that is, long enough to contain the other side, as AB is equal to AF. We need to somehow transfer the length of AF to get the point B. Page number 201. How do we do it without a ruler? Can it be done using a compass? Observe how the length of AF is measured using a compass. Use it to mark out the points B and C and complete the rectangle. We are provided figures in which we can see that we are using compass to mark the points B and C. With this idea, try constructing a rectangle that can be divided into three identical squares. Give the lengths of the sides of a rectangle that cannot be divided into two identical squares, three identical squares. Construct. First one, a square within a rectangle. Construct a rectangle of sides 8 centimeters and 4 centimeters. How will you construct a square inside? As given in the figure, such that the center of the square is the same as the center of the rectangle. Here we are provided with a figure in which the length of the rectangle is 8 centimeters and breadth is 4 centimeters, and we have a square inside this rectangle. Page number 202. Hint: draw a rough figure. What will be the side length of the square? What will be the distance between the corners of the square and the outer rectangle? Second, falling squares. Here we have the picture of three squares which are touching each other diagonally. Each is a square of side 4 centimeters. Make sure that the squares are aligned the way they are shown in the picture. In the second figure, we have square of side 3 centimeters which has another square of side 5 centimeters and another square of side 7 centimeters. Third, shadings. Construct this. Choose measurements of your choice. Note that the larger four-sided figure is a square and so are the smaller ones. Here we have a picture in which the squares have been divided into equal halves and halves of the squares are shaded. Page number 203. Fourth, square with a hole. Observe that the circular hole is the same as the center of the square. Hint is, think where the center of the circle should be. Here we have a picture of a square with a circle inside it. Question number 5. Square with more holes. We have a picture of a square with 4 squares inside it and 4 circles in each square. Sixth, square with curves. Think of a square with 8 cm side length. Hint is, think where the tip of the compass can be placed to get all the 4 arcs to bulge uniformly from each of the sides. Try it out. We are provided with a picture of a square and 4 bulging curves inside the square. 8.5 Exploring diagonals of rectangles and squares. Consider rectangle PQRS. Join PR and QS. These two lines are called the diagonals of the rectangle. Compare the lengths of the diagonals. First predict the answer. Then construct a rectangle marking the points as shown and measure the diagonals. We are provided with a picture of a rectangle PQRS with diagonals PR and QS. Also, the angles are marked as A, B, C, D, E, F, G and H from points S, P, Q and R respectively. Page number 204. In rectangle PQRS, the right angles at P and R are referred to as opposite angles. The other pair of opposite angles are the right angles at Q and S. Observe that a diagonal divides each of the pair of opposite angles into two smaller angles. In the figure, the diagonal PR divides angle R into two smaller angles which we simply call G and H. The diagonal also divides angle P into C and D. Are G and H equal? Are C and D equal? First predict the answers and then measure the angles. What do you observe? Identify pairs of angles that are equal. Explore. How should the rectangle be constructed so that